Hi, good evening, everybody. So, we're going to discuss today about spanning tree protocol. So, before going spanning tree protocol, let's understand what is a spanning tree and what's the use of that and why should I study this first. So, a spanning tree protocol in the short form, this is called STP. What is called? STP protocol. So as for spanning T for tree and P for protocol. So this protocol belong to layer 2 infrastructure. Layer 2 infrastructure. What do you mean by layer 2 infrastructure? What do you mean by that? So there is 7 layers of OSI layer. If you remember, we have already application. Tell me what's the next layer after application. Tell me presentation. Tell me after presentation, guys, session layer. Then we have transport layer. Then we have network layer. Then from the network layer, we have data link layer. And at the last, we have physical layer. So today we're going to study about the example of protocol which belong to layer 2. This is layer 1, layer 2, layer 3, layer 4, layer 5, layer 6, layer 7. So today we're going to study about layer 2 protocol. Means for the data link layer, this protocol work. Okay, a spanning tree protocol, a spanning tree protocol. First thing here. Second, this is the standard protocol. It's registered affiliated with the IEEE. This is called, that's why this is called IEEE layer 2 protocol. Layer 2 protocol. Okay. In interview, they will ask you, so you have to first sentence you need to tell. A spanning tree is a IEEE layer 2 protocol. IEEE is an organization who manage, verify, test, and organize the every end-to-end testing with the every vendor, and that going to be registered, validated. That protocol is global applicable. Okay, so today we're going to study this. So in the rough way, we're supposed to understand why do you need this. Okay, and then we will go for how it's going to work in the layer 2 infrastructure. Okay, let's understand. So we have switches. So this is layer 2 protocol. So this is going to run on layer 2 device. So layer 2 device, we have switches. That's a great example. What is the layer 2? Layer 2 device name are switches. Example is switches. For layer 3, what is the example? The example are router. For layer 4, what is the example? We have what is called firewall. Firewall. So that's This way, like for layer 7, every layer we have an example of device. So layer 2, a great example, layer 2 switches. We have layer 2 switches, layer 3 switches, but we are talking about today layer 2 switches. Then we will see how the spinning tree work on layer 4, layer 3 switches later on. So first understand, suppose we have, this is switch 1 and we have 2 switches. Okay, so we have connectivity between the 2 switches so that they can talk to each other, they can communicate to each other. Switch 1 can communicate to switch 2 using this cable, the connectivity. Okay, suppose while this communication is established and communication is going on and this link is breakdown, so communication will break and the connectivity of switch 1 to 2 will dismissed. Okay, so in order to avoid this kind of situation, very simple, we need switch 1 and switch 2 having multiple connectivity, so that if in case any link goes down, so my communication should not break. So we need multiple connectivity. We need multiple connectivity. Suppose any connection break, so my communication should not break. So this technique called redundancy. So where we are, redundancy. Now the third term is called redundancy. Redundancy. What do you mean by redundancy? If one switch having multiple way or multiple connectivity to establish the communication with the switch 1 to switch 2. So here I took the example of 2 connectivity. So let me now, here it's clear both of you understand the 3 terminology what we have discussed, guys.
Yeah, yes, sir.
Yeah, so
Yes, sir.
first terminology IEEE, second layer 2, and third is what we have, third one, that's a
Layer two.
redundancy.
Yeah.
So redundancy says that if by mistake the communication going to, sorry, not the link will down, your communication is still well live. If the communication happening through this link earlier, push data and this link is down, this communication will, data will switch to the other link. Okay, so we need redundancy to get the my uptime communication always up. My communication should not down, even any port or any link goes down from one switch to another switch. Very simple. In order to achieve this, the due to this, the problem is created. What is the problem? So as soon as I will have 2 link in place, let me draw again. Suppose switch 1 is here and switch 2 is here, and we have 2 link. I'm taking only 2 links so that if you understand for 2 link you can understand. So what's the problem is that, so once we have 2 link, so when switch will send some packet to switch 2 at the layer 2 level, it's called not packet, is called frame. What is called? The communication units called frame. So switch 1 send the frame to switch 2, that's the data. So it will send to the link 1 and link this. Suppose link 1, this is the link 2. Suppose link 1, link 2. It will send to the link 1 as well as link 2. So same frame will reach here. Same frame will reach here. And he will think, switch 2 will think, because I received the frame from switch 2, I will send to this frame to on this link, because they behave this link as an individual. Is thinking that the data which I receive on the link 2, link 1 does not know. Same way, whatever the data he will receive on the link 1, it will send to the link 2 also. Because switch 2 will think that the data which coming from link 1 is a X, the data coming from on link 2 is a Y. So let me send the Y to link 1 and let me send the X on the link 2. So you can see, first of all, one frame had copy of 2 first for the link 1 and link 2. Then again multiple copy it's came to here. Multiple copy it's become after when come to here, because he sent to link 1 and then link. And then it will reach to the link 2. Again it will copy and it will send to this and then this. What going to become? It's going to become the loop. And due to this loop, both the switch going to be hang, because same data is keep on coming and getting copied. Okay, it's a career. It's a career, guys, till here. Okay, it's a very simple. You understand the multiple copy going to be bring. So let's understand, in order to avoid this, due to redundancy, we have to maintain the redundancy, but we have to avoid the loop. So there is a protocol. There is a protocol developed that is called a spanning tree protocol. So what is a spanning tree protocol? So 4 keyword: redundancy, loop, IEEE layer 2. So you can say that the definitions of the spanning tree protocol. A spanning tree protocol is a IEEE layer 2 protocol which maintain the redundancy by avoiding the loop. By avoiding the loop. This is a sweet and simple definition. You can add more one line to introduce with the some of the attributes. So we're going to study now attributes. Okay, so my purpose, you understand, there's two switch we have connected in order to receive the redundancy, so that we can achieve the, if any link goes down, even though my communication should not break. In order to achieve the redundancy, we got the loop. We have to avoid the loop. In order to avoidance of loop, the protocol which is used on layer 2 infrastructure, that's a spanning tree protocol. Clear? Let's understand the attributes which help you this to make it loop free infrastructure, even though we have multiple link, okay, in the infrastructure. Should I start understanding the component or element associated with the spanning tree? Let's discuss one by one element which help to achieve our objective even though we have redundancy link to avoid the loop. Okay, so for that I made the slide. So in the slide we will see the redundancy link, you can see that. Then we will see the layer 2 loops, multiple copy of frame because we making the multiple copy of frames. Then we will see the MAC table instability. What is MAC table? They maintain this frame address on the MAC table. That going to be keep on changing. We will see how. And then at the last terminology called broadcast storm. What is broadcast storm? We will see that. Let's move the topic and understand one by one. Redundant link. Now I need your participant. What do you mean by redundant link, guys? This is very simple. If the two switch or multiple switch connected with the more than one link, okay, or more than one way to communicate to each other. Let me give you another example, then it will be more clear. I'm going to check this. Let's understand. So this is redundant link says not only the two switch having two link. That's this depend upon the topology. This is the one example what I gave you. You need two link for redundancy. But if we have three switches, switch 1, switch 2 and switch 3, so you can see even we have one link connected with the other link, it will create the loop. Who had joined? Someone had joined or someone has dropped. Okay. So you understand this part? Even though it's not connected to the same switch, they will create the loop because it will send to this, it will come to this, again it will send to this, and this frame again come to this point. Switch 1, now switch 1 will understand I send here, so I receive something here, that's a new one. So he will send again this because he's thinking it's a new. So we redundant, both the things redundant. Both the form is depend upon topology. Redundancy, if one switch can get the same frame, okay, this is called. So you can see this loop, L2 loop. When the switches form the loops, that is called L2 switch. Means L2 devices at the layer 2 they form the loop, that is called L2 loop. This is formed by the layer 2 switches, and that's going to be avoided by the spinning tree. Okay,
So,
clear?
sir, I have one question.
Yes.
So, in the redundancy, can we add more than two devices?
Yes, of course. We can add not only to see, you can see here I have added three devices. Let me
Yes,
make four devices.
yes, added. But here, na, as per the structure, some loop is being created, na?
Yes, we're going to study how to avoid the loop by using the spinning tree protocol. A spinning tree having intelligence to calculate something, some logics they're going to apply.
Yeah,
So logical topology will be different from the physical connectivity. Okay. So for
yeah.
that we are going to study that. So we are understanding first what the terminology, the redundant link. So you have to use this kind of terminology while you are speaking in interview. Okay, this is
Yeah,
very important concept for interview. Every interview they will ask you question. So please thorough understand this. So loop due to the redundant link. If there is no redundancy, there is no means. If someone going to ask you, let me give you an example. And suppose you have switch 1, switch 2, switch 3, switch 4, and that's all. And it's connected with each other. So in this environment, there is no loop creation, but there is no redundant link. If any link going to be down, the communication going to be break. The communication going to be down. So in order to establish it, so I have to connect this switches like this. Suppose some connectivity goes down also, they have communication established. So while we are connecting this physical connectivity, so logically they will make the unique at a time of communication there is only one best way to communicate. Once any link goes down, the spanning tree going to recalculate the best way. So a spanning tree protocol is nothing. They're going to run the protocol and they find the best way to reach from source to destination in the L2 infrastructure. If some link goes down, they will again recalculate what is the new path available in layer 2 infrastructure reach from source to destination. I hope I met this video. Let's understand how it's happened. What are the terminology associated? What are the attributes associated which help to achieve this object? Okay, so
yeah,
let's understand multiple copy of. Okay, we already understand this part. Multiple copy of the frame. Okay, now next topic is called MAC table unstable. What going to be happen? Let's understand MAC table unstable. How this is very bad. I'm going to take the screen. So let's draw three switch here and understand this MAC table unstable. How it's make the MAC table unstable. So first understand what do you mean by the MAC table. MAC table is nothing. Three things. Whenever they are telling MAC table, three things. This is a layer 2 address. What is this? Layer 2 address. The layer 2 address is used to reach from source to destination. From source to destination. This is layer 2 address. The switch is intelligent. They maintain the MAC table. What they maintain? Something called
back.
MAC table. What is in that? There is a MAC entry. There is a MAC entry associated with the VLAN and having the port number. Having the port number. We will do lab and we will understand this thing. Don't worry. We will spend the quality time over on each and every. So there is a MAC table in that. Okay, and there is a VLAN associated with that and the port number. Why this is required to maintain MAC table? So that if switch, suppose these switches are connected to each other, if any frame comes to this switch 2, he will look in the MAC table and he will check this switch where to want to go. So there in the frame there is called source address and something called destination
Exactly.
address. Destination address. So we have source address from where you are coming, destination address to where you want to go. This map table will check the destination. Okay, you want to go for XYZ. So let me look in my map table. So he found the map table entry. Okay, this is the map table entry. So you go to this way. Means you can go out with this port now. So Mac table, this is the Mac table. Now, what going to be happened when it's a loop will create? The frame will coming from this. It will go here. It will make the entry, and how he will update the Mac table on the basis of source Mac, because you never know what is destination, where the destination exists, but you know about your source. Everyone know about your source. If someone going to ask your name and you are telling, I don't know my name, this is not possible. At least you know your name and from where you belong. That is your source. So Mac table, what they do, from the source table, they will do the entry on my Mac table. So Mac table is nothing. This is a source address entry, so that they will get, okay, this is belong to there. If someone want to look for this, I will tell them, okay, he is belong to this port. Go for that port. What going to happen while they is entering here as a source? So this frame will go out from here, and it will come to this way because of loop. Because of loop. And what going to happen? A few seconds earlier, he make the entry. The source belong to this port. Now he will change the source belong to this port. The same frame keep on rotating, and he keep on changing the port from this port to this port to this. So due to this, the Mac table keep on editing, and there is no fixed Mac table. Mac table become unstable. So what's wrong with this? Because Mac table maintaining the memory RAM will it will going to be run out with this memory, and CPU going to be very high because keep on changing on the Mac table. So this is very bad effect. The your switch resource going to be consumed highly, and it is stop working because the switch get stuck into the loop. It will not able to process with the new frame. Okay, so there is no memory, there is no. So Mac table instability, this is the very bad scenario for the any layer 2 infrastructure. Now come to broadcast strong. What is broadcast strong? As I explained you here, in the first scenario, if you see, go to the first one, previous scenario. So due to this loop, this is create the broadcast strong. Loop over loop. One loop is not over, another loop is there. There is so many loops of loops. And this loop's going to make both the switch hang. So these are the terminology you're supposed to use in the interview. A spanning tree is a very, very important. A spanning tree is used to avoid layer to loop, multiple copy of frame, Mactable instability and broadcast strong. Here guys, comfortable. So this is your definition. This all the terminology supposed to come into your definition wherever you're going to define the spanning tree in interview. If you forget one terminology, it does not matter. But out of this six terminology, you should try to use all the six. Let's repeat with me, everyone. Let's repeat with me. First, redundant link.
redundant link,
Layer 2, loop.
layer 2 loop,
Multiple copy of frame.
multiple copy of frames,
Mac table instability.
Mac table instability,
And broadcast strong.
and broadcast term.
So let's define the spanning tree protocol. मैं define करता हूँ. देखो कितना easy हो जाता है if you understand this six terminology. Okay, a spanning tree protocol is a layer 2, or you can say IEEE layer 2 protocol, which maintain the redundant link in order to that it's avoid layer 2 loop, multiple copy of frame, Mactable instability and broadcast strong. See, your definition going to be the potential valued. Have you think about a spanning tree going to define in this way? If you forget one of the keyword or two of the keyword, does not matter. You have mentioned 4 to 5 keywords. So this is the definition. Let's now go for next. Comfortable guys? Each and every terminology is clear.
Yes, sir.
Great, thank you. Means you understand 50% of your problem. What is the problem in layer 2 infrastructure? Okay, let's move to the next. Means next thing. Let me erase here. Okay. What is next? A spanning tree protocol. We're going to continue. Default a spanning tree configuration. What do you mean by default? What do you mean by default?
Mm,
Default means suppose you got one package. In that
yes.
there is a 5 thing. One pen. Suppose you got the study package having the pen, pencil, one notebook, and one small carry bag. They are telling in package this is default one.
Yeah.
So means a package having one carry bag, small carry bag, one notebook, one pencil, one pen. If you want to buy something like painting or color box, you have to buy, right? But the default having 4 quantity. Clear?
Yeah.
So a spinning tree, as soon as you buy a switch, there is a spinning tree running by default. The default spinning tree, there is a default thing already available. So let's understand. I'm not going to do any configuration. Let's understand by default what are the things available in a spinning tree. So a spinning tree having so few things that is called native VLAN 1, default spinning tree for VLAN 1, BTY, domain name null, and mode is server. Let's understand each and every terminology, and we will make this clear, and we're going to study twice, thrice these things. Like BTP domain, we're going to study, like a spelling tree protocol we are studying, we're studying again. So today we will try to understand the BTP domain in the small way only. Later on we will understand complete lab we will do. Okay, so we will try to understand what are the default thing running on the switch. So I'm not going to teach you theory. Let's jump to the switch and understand by taking an example of switch. Okay, let's move, jump to the switch. So I'm going to, okay, let me go to on packet tracer. So I'm going to open my terminal and we run the packet tracer. So I hope everyone installed the packet tracer successfully till now. So these are the routers. So we are not talking about today router, we are talking about the switches. So these are the switches 2960. There's empty switches also for testing packet tracer switches. We have 2950, 2950T, 2950 24 port, 3560 24 port, 3560 24 PS, 3650. So I'm going to do layer 2. These are the layer 3 switches. So we'll take one example of all 2960, 2950, because tomorrow you will go for interview. You should not say, oh, I work only for 3560. I did not work for 3650. So what are the model do we have, guys? So I will write here model as a name so that you can refer this. Okay, so let's give the name first. So what is this model? 2960 switch model we take. So I will give the name. How are you going to configure the name? Go to the config. Here you can do display name and host name. So I will keep both the same. It's a best practice. What you display, the host name should be same. You can keep both the different, but here I'm going to keep so that 2960 model. Try to remember for interview they will ask you what are the switch model you have worked. Oh, I'm going to write 2960 and I will save this. Okay, then I will open the CLI so you can see this configuration by default they given by. Are you able to see my screen?
Yes,
Okay,
yes.
this is my 2960 switch model. Next we have 2950. I will give here, I will give the right the name 2950. Follow with me as I am practicing. Please follow this way so that you can get benefit, maximize your benefit to switching having different complete different world. You will not get enough resources for practicing, so this is the best place to practice. So 2950 model, so in your resume you can say that you have to keep this. Okay, now you have, that is the model 3560 switches, what is called T560 switch. Okay, I'm going to copy. Please, you also you can follow this from with me. Next time onward I will ask you while I'm taking class, please do the exercise with me. Otherwise you guys not able to do the practice at all. So I'm writing very simple way. I'm writing follow the model then switch, follow the model then switch name. Okay, I'm not giving switch. Okay, it's a power on still. Let's wait. Power is powering. It's going to take 3650 switch. I have still it's the device must be power on. We have to see where to power so you can drag and this. We have to power on the device. Where is the switch? Can you able to see the switch? Zoom in. Okay, there is a power slot is missing. You have to connect the power slot. Is that so?
No.
No. Module powers. Let me click. This is the AC power supply. Yes, this is the AC power supply.
Yeah, right.
Let me connect this again to power supply. Where is the switch on? This is the switch on. Okay, I got it. Just connect one power supply and then go for config. They keep on changing few things. Okay, you have to try and do that. Okay, so this is a new model. 3650 was not earlier introduced. It's newly introduced in the packet tracer 3650. So you have to connect the power. That's a simple logic they do. Just connect one power and that's a switch on, because there is no switch on off on this actual model. In 3650 switches there is no actual switch on or off, means from the rack it's going to be on and off. So that's why you have to connect them power AC power supply, it will be automatic on. So I'm going to stop here because time is, there's no time left for the today's session, and I'm going to write all this so that we can continue from here from the next class. Okay, if you have any questions, let me know. Let me first, I'm going to save this topology. How are you going to save? Whenever you do your work, you can save your work. How? Just you do the right and then click file, save as. This is the first time I'm doing, so I will do save as, and you can give your design name. So a spanning tree protocol, spanning tree protocol, spanning tree protocol, and you can followed by the date or anything you want. So today's date is 17 Jan. That's going to be unique code. Just I'm going to save this. So this topology is saved. So I'm going to stop this session. We will meet you in next class. Bye bye. See you in next